What if we erased everything? Every galaxy, every atom, every particle, every law of physics? What would remain? The answer seems obvious. Nothing. But the more scientists, philosophers, and cosmologists explore this idea, the more we realize that nothing might be one of the most complicated concepts in existence. In everyday language, nothing means a complete absence, a void. But in physics, nothingness is far from empty. And the question, why is there something rather than nothing, remains one of the most profound mysteries in science. Let's start with what modern physics tells us. In quantum field theory, empty space isn't truly empty, even in a perfect vacuum, where no matter exists and no light passes through. There are still quantum fluctuations. Tiny blips of energy appear and vanish in a fraction of a second. Particles and antiparticles pop into existence and annihilate each other. This seething foam of activity is called quantum vacuum energy. This nothing is actually something. It has measurable effects, like the Casimir effect, where two metal plates placed close together in a vacuum feel a tiny force pushing them together due to quantum energy differences. It even contributes to the expansion of the universe through dark energy. So from a scientific perspective, nothingness is never truly nothing. But what if we stripped away even quantum fields, space-time itself, the rules of physics, and even mathematics? Could we imagine a true, absolute nothing? Some philosophers argue that this state is logically incoherent. If there's no space, no time, no logic, no possibility, then the very concept of nothing collapses. Because to define nothing, we must use something: language, logic, thought. Others suggest that nothingness might be unstable. That is, perhaps nothing is not a permanent condition. If nothing is possible, then something could emerge from it simply because nothing prevents it from doing so. This idea is echoed in quantum cosmology, where entire universes could arise spontaneously from fluctuations in a quantum vacuum. This is the basis for one of the most exciting and debated ideas in theoretical physics. The universe could have created itself from nothing. Physicist Lawrence Krauss popularized this notion in his book, A Universe from Nothing, suggesting that the laws of quantum mechanics make it possible for entire universes to spontaneously pop into existence. According to this view, no external cause or creator is needed, just the laws of physics themselves. But critics point out a key issue. If the laws of physics exist before the universe, then that's not nothing, that's something. A background framework that allows reality to emerge. So maybe the real question isn't how something comes from nothing, but rather whether true nothingness is even possible. Religious and metaphysical views. Many religious and philosophical traditions also engage with the idea of nothingness. In some Eastern philosophies, emptiness is not a void, but a creative potential, the fertile ground from which all things arise. In the West, theologians have long debated the idea of creation ex nihilo, creation out of nothing, as a way to explain divine creation. But even here, the debate continues. Is nothing truly a starting point, or is it simply the absence of what we currently understand? Mathematical and logical nothing. In mathematics, the concept of zero was revolutionary. It allows us to define absence in a meaningful way, but zero is still a value. Similarly, the empty set is a defined object in set theory. It's not nothing, but a set that contains nothing. Even a null space in linear algebra is not truly nothing. It's a space defined by the solutions to an equation. We keep coming back to this. Every time we try to define nothing, we end up constructing something. So maybe the universe doesn't come from nothing. Maybe it comes from something we mistake. as nothing, cosmogenesis and space-time birth. In some cosmological models, space-time itself is an emergent property, not fundamental. For example, in all-loop quantum gravity, space-time is quantized and emerges from more basic, pre-geometric states. In string theory, the universe arises from vibrations on a multidimensional membrane, a kind of pre-space where conventional nothingness doesn't apply. Could our universe have tunneled from a previous state? From a non-being to being? If time doesn't exist before the Big Bang, then perhaps before has no meaning. This brings us to the concept of timeless creation, the idea that the universe's origin is not an event in time, but the emergence of time itself. So, what is nothing? The answer may be, we don't know, but that's okay. Because in asking what nothing is, we're really asking what everything is. We're confronting the edge of knowledge, where language, logic, and mathematics begin to falter, and wonder takes over. At infinity beyond, we believe that exploring the void isn't about darkness. It's about Oz depth. It's about staring into the abyss of the unknown and realizing that even the idea of nothing is richer than we ever imagined. In our next episode, we'll explore the origin of the laws of physics themselves. Where did they come from? Could they be different? Or are they written into the very essence of existence? Subscribe now to Peace Infinity Beyond and keep questioning. Even when the question is, what if there was never anything at all?